Have you ever stopped to think about the text on your screen? What if it wasn't just a static block of words? What if it could be a dynamic, interactive interface? Well, today, we're going to dive into a really fascinating piece of engineering that makes exactly that, a living text, a reality.
I mean, seriously, think about it. When you interact with text on your phone, trying to select it, highlight it, it's usually such a clunky experience, right? You're always fighting with these rigid, unforgiving boxes. But why does it have to be that way?
So look at this. On the left, that's the standard clunky experience we all know. You get these disconnected, blocky rectangles. But on the right, that's something else entirely. It's a fluid, almost organic shape that seems to actually understand the words it's covering. And that is the core idea behind creating a living text.
Okay, so to really get how they built the solution, we first have to understand the problem. And it has a great name, the tyranny of the rectangle. See, the standard tools that developers use, like Android's text view, they're just fundamentally built to draw text inside these really simple static boxes.
And look, these standard components are totally fine if all you're doing is displaying text. But the second you want to do something more complex, like that beautiful multi-line highlight, you just hit a wall. You get all sorts of weird visual glitches, and performance goes right out the window. It became pretty clear that a totally new approach was needed.
And that new approach? Well, it was basically to throw out the old rulebook and build a custom rendering engine from the ground up. The solution is this really cool multi-layered system, all built on a single, powerful drawing surface called a canvas.
Everything starts at layer 0, the foundation. The best way to think about this is like a painter priming their canvas. This is where those beautiful, custom shapes, like our smooth, multi-line highlights, are drawn first. It's all about laying down that underlying geometry.
Next up, layer 1. This one's pretty simple. It's just the text itself. It gets rendered cleanly right on top of the background geometry we just created, making sure everything lines up perfectly, right down to the pixel.
Now, layer 2 is where things get really clever. You can't see it, but it's basically the engine's brain. It's constantly listening for your touch, mapping your taps and drags with incredible precision to the exact word or character you're aiming for. This is the secret sauce that makes the text feel so responsive.
And finally, layer 3. This is the visual payoff, the magic on top. This is the layer where all the dynamic elements pop into view, things like connecting lines, arrows, maybe even words you can drag around. It's this whole layered approach that lets you have such rich interactions without the entire system just falling apart. So we've got the layers, but how does the engine actually draw those beautiful, intelligent shapes? Let's get into the geometry and the clever algorithms that give this text its visual meaning.
For those slick multi-line highlights, the engine uses something called the staircase path algorithm. So instead of drawing a bunch of separate rectangles for each line, it identifies all the lines the phrase crosses, and then it constructs one single unified path that flows between them. It even uses these smooth curves at the corners to give it that really polished, rounded look. So cool.
But what if you want to connect two related words that are far apart on the screen? For that, the engine uses what are called Bezier connectors. You can think of them as these smart, elegantly drawn curves that create a visual link between ideas, but without ever getting in the way or covering up the text.
And these connectors aren't just random lines. They follow a really smart set of rules. For example, the arc of the curve actually gets higher the farther apart the words are. The curve shape also changes depending on whether it's pointing up or down. And maybe most importantly, it's smart enough to actively avoid colliding with other words on the screen.
Okay, but here's what I think is the truly genius part. It's not just how these things are drawn, it's about what tells the app to draw them in the first place. You'd probably think all this complex logic lives right inside the app, right? Well, in one of the most powerful design choices here, the app itself is actually just a powerful renderer. The real brain is in the cloud.
See, the server sends a super simple set of instructions to the app in a format called JSON. You can think of it like a recipe. This little snippet here, for example, is basically telling the app, hey, draw a connector, an anaphora type, from word number 8 to word number 23. That's it. Just simple, clear instructions.
And here's why that is a total game changer. By having the server define all the logic, you can introduce entirely new kinds of interactions and exercises without ever needing to push out an app update. This gives the creators this incredible flexibility to constantly experiment, iterate, and improve the experience on the fly.
Of course, whenever you hear about a custom-built engine like this, the big question is always the same. How does it actually perform? Can it run smoothly on a real phone without melting it?
Well, the answer is a resounding yes. The engine consistently hits a buttery smooth 58 to 60 frames per second. And that's not on some fancy new phone either. That's on mid-range devices. For you, that just means no stutter, no lag, just a perfectly fluid experience.
And get this, it does all that without being a memory hog. The engine is incredibly efficient, using only between about 2.1 and 3.4 megabytes of memory per screen of text. That's remarkably low for what it's doing.
And you should know, this isn't just some tech demo. This engine has been properly battle-tested. It's passed over 120 different testing scenarios. We're talking different languages, screen sizes, interaction modes, the whole shebang. It is robust and absolutely ready for the real world.
This summary table really just says it all, doesn't it? A super high frame rate, incredibly low memory usage, and extensive testing. It's a solution that isn't just elegant in its design, but it's also incredibly powerful and efficient in how it actually runs.
And all this brings us to the final, and I think most important question. This engine is way more than just a cool piece of tech. It's a real glimpse into a future where text isn't just something we passively read, but something we actively interact with. So, when text itself becomes the interface, how does that change how we read, how we learn, and even how we play? What do you think comes next?